Assalamualaikum. Today we would like to talk about reasonable material classification by using convolutional neural network (CNN). My name is Noor Amira Nabila binti Zamzuri. My matric number is AA180015 and my friend Noor Atika binti Muhammad Zakri CE180056. Introduction. The classification of image has become a challenge. Nowadays, technology has rapidly progressed from analog to digital. What actually the convolutional neural network? The convolutional neural network (CN) is a type of artificial neural network that is specially designed to process the pixel input. CNN are image processing artificial intelligence (AI) system that employ deep learning to boost generative and distractive tasks. Multi-layer perceptron are typically completely connected network, meaning that each neuron in one layer is linked to all the neurons in the following layer. For methodology, neural network is used to analyze, recognize, and detect image in image data. There were 5 layers in CNN architecture, which is an input layer, a convolutional layer, a pooling layer, a link layer, and an output layer to make up of the CNN architecture. The pooling layer become a fully connected layer as a result of the activation function as seen in figure 1. This for the figure 1, we can see this is the 5 layer of CNN architecture. The second picture show the CNN layer. Next, convolution layer. So convolution layer is up to a kernel, which is also known as a filter and can be utilized in a sliding window. The picture below show how it works. So this is the original image, 6 multiply 6, and then after that we convolution it, we filter it in 3 multiply 3. After that we get the output by 4 multiply 4. For example, the -7 is the result of the elemental wise product and the sum of the filter matrix and the original image. Next, pooling layer. So pooling layer is used to reduce the picture volume since it has filter that define size and shift, which is typically done using 2 multiply 2 window and strike 2. The picture below show how it works. Next, fully connected layer. It takes the input from all of the convolutional and pooling neural in previous layer, and then it performs the operational with each neural in the current layer to get the output display. The picture below shows the connection of the layer. Next, I pass to my friends. Thank you.
Assalamualaikum, my name is Noor Atika binti Muhammad Zakri and my matric number is CE182056. So I am going to explain about the simulation part. So this is part 1 of our assignment. So this is part 1 of our assignment. So first step is we have to connect to the Google Drive. So from here, from Google Lab, we have to import our drive and to link with the drive. So we just run here. As you can see here, the drive already connected with the folder. Step 2 is to feed dataset directory. So we have to import the data from the G drive. So here, as you can see here, from the folder G drive and my drive, and open collect notebook and search our folder. This is our folder for this assignment 2, BAJ34202. So we just copy paste here and just run. Okay, for the step 3 is we have to create the train and validation data directory. So we just paste paste our link here, and until we paste the link here, we just run, and the data will calculate the value in this image sorry. So for the step 3 is we have to create and validation data directory. So we have to copy paste our link here. So after we paste our link here, we run, and we will get the result. And this is our result. As you can see here, dot string length 156, cat string length is 310, for value length is 77, and for the cat value is 123, and dot test length is 4. So here we just run also. So for the part 1, we have to construct the CCM model. So here we just run again. So you can see the result here. And we have 3 parameters: total parameters, turnable parameters, and non-turnable parameters. So in this step, we have to get 0 parameter. So after that, we have to skip this part because this part is for part 2. Okay, we skip to the step 5, pre-process the input data. So we have to run this also. After you run, we get this result. We found 466 images belonging to 2 classes. We found 210 images belonging to 2 classes, and database for the shape is 20, 150, 150, and 3. So the label base for this shape is 20. So after that, for the step 6, if we start turning the process. So here we just run also. So we use epoch data 10 because when we use above than 10, the result we get some time to code the coding. So we use 10 only, 10 value only to get the epoch data. So as you can see here, the data is simulating from 1 until 10 because we set the epoch is in 10 value. So we have to wait the data to complete. Okay, as you can see here, the data is fully complete, and is our result for the epoch data. We get 1.000, and this is the accuracies of the BGP. So we have to plot the outcome. So we just run the code here, and we will get the graph. So this is the training and validation accuracy. As you can see here, VDD is better than CNN for the part 1. Okay, here
finish, you just leave the classroom. Not to recall. It's okay. The class all of you.
谢谢老师。So for the code, so for the coding here, we just run. So we get the percent is 0.0%, and so also we just run here, and we get 100% for can and 100% for pet. So also this is coding for the 3 image that we capture with our phone. Okay, that's all for the part 1, and we proceed to the part 2 simulation. For the part 2 simulation, the process is still the same from step 1 until step 4, construct the CCM model. So for the part 2, we have to run. So for the part 2, we have to run step 4, construct frame model with BGT. So we have to run this for the part 2. As you can see here, the data is already finished. So the total parameter for the step 5, pre-process the input data, we have to run again for simulation part 2, and we get this data. So after that, step 6, start training process, we have to run again. So epoch we still use 10 value. So after we finish the equals data, so as you can see here, the equals data, we get the accuracy 1. So VDD is better than VCN, as you can see here. After that, we plot the outcome to see the graph. So as you can see here, this is our data. So we will get the different graph from our report and the data because there will be a bit simulation here. Okay, that's all from me for the part simulation. Thank you. Analysis for part 1 is the system will be planned to recognize the object, whether the object is pet or can. The picture of object to detect the classification of the object with 3 conditions to test. We've just picked 10 equals to make it easier to run. If it's too many equals, it will take time to run. For the part 2, we selected the preferred model to test the classification of the system to run. Select VGJ and ResNet to test the system to run, and the accuracy and loss of the training validation in the picture. So for the conclusion is, we use Google Colab as a method and concept for developing the vision system. A good team effort was organized to build a complete vision system module for a specific application, including mechatronic system. CNN can outperform a human at visual recognition tasks when given a well-prepared dataset. They are, however, nonetheless vulnerable to visual distortions such as glare and noise with human and composite. That's all from our group. Thank you.